The integers a, b, and c form a geometric progression in this order. A, b, and c minus 64 form an arithmetic progression. A, b minus 8, c minus 64 form a geometric progression. Find c. Now let's try to represent all of these variables using something similar. We have a, b, and c, and they form a geometric progression. We can keep a, but let's call b aq. Q would be the common ratio in this progression, and c would be aq squared. And we know that aq and aq squared minus 64 form a arithmetic progression. And we have another geometric progression with aq minus 8 and aq squared minus 64. Now let's try to write some equations. For geometric equations, we know that the middle term squared is equal to the terms on either ends multiplied together. It's pretty straightforward for this first one, so this equation won't really help us. For the arithmetic sequence, the middle term is equal to the mean of the first and last terms. And for this final geometric sequence, again, the middle term squared is equal to the first and last terms. So here we have two equations that can be put into systems and two variables that we're solving for. So this is possible to get a solution. The first equation becomes 2aq is equal to aq squared plus a minus 64. And the second equation becomes a squared q squared minus 16aq plus 64 is equal to a squared q squared minus 64a. This a squared q squared term appears on both sides, so we can further simplify. We can multiply this equation by q. Doing so, we get 4aq minus aq squared plus 4q is equal to 0. We see that aq squared is equal to 4aq plus 4q. And from this same equation, we know that aq is equal to 4a plus 4. So bringing it into this equation, we see that aq squared is equal to 16a plus 16 plus 4q. Now we can substitute this into our first equation. We get 2aq is equal to a plus 16a plus 16 plus 4q minus 64. 8a plus 8 is equal to a plus 16. We get 9a plus 4q minus 56 is equal to 0. We can try to isolate one of the variables, so let's isolate q. Q is equal to negative 9a over 4 plus 14. Now let's substitute this into this equation. Doing so, we get a times negative 9a over 4 plus 14 is equal to 4 plus 4a. We're left with this quadratic. Let's apply the quadratic formula to solve for a. A is equal to 40 plus or minus negative 40 squared minus 4 times 9 times 16, all of that over 18. When we simplify, we get a is equal to 20 plus or minus 16 over 9. This means a could equal either 4 or it could equal 4/9. However, a must be an integer. They said that earlier. So A has to be equal to 4. And it's asking for C. If A is equal to 4, then Q is equal to 5. C is represented as A times Q squared. So 4 times 5 squared is equal to 100. So C is equal to 100, and that is our answer.